All right, if you haven't already completed the Are You a 5-Star Uber Driver side of this note sheet, go ahead and pause the video and do that real quick because it will help understanding the intermediate value theorem a little better. All right, so for number one, there's just some things to think about. Sometimes students say sketchiness and things like that, but and having snacks and different things, but that's some things I thought about. All right, so two, must there have been a time during the trip when the odometer read exactly 8 miles? Definitely. You cannot skip over 8 miles to get to 17.5. And so one note about that is that distance is continuous. You can't jump space. Okay, and so we want to go from Long Island to the Museum of Modern Art, and they are 50 miles away. So it's possible that at some point they were 53 miles away because you could have had a detour, you could have driven in the wrong direction, but there doesn't have to be a time when you were 53 miles away. So we would say that we cannot guarantee, so not guaranteed values outside of 0 and 50. Because you could have driven straight there. Alright. So we're wondering if the first trip was 2 passengers, the last trip was 4 passengers, could there definitely have been one in between that was 3 passengers? And that's no. The number of passengers in each trip is unrelated. So if you're thinking about number of passengers as a function, that it would be not continuous. All right, so all of this Uber driver stuff is leading into the intermediate value theorem. And intermediate basically means between. So this is the between value theorem. So a lot of times when we're talking about the intermediate value theorem, instead of saying all the words, we say the IVT. And it's used to prove a certain Y value must exist. All right, so we have to use this theorem, the function must be continuous on the interval from A to B. Then f of x attains, or we could say hits, every value between f of A and f of B. So it's like that distance one. We're traveling 17.5 miles. Distance is continuous, so we have to hit every mile between 0 miles and 17.5 miles. So this is the condition. And then this is the conclusion. So what we have to do to prove the existence of a Y value is first verify the condition of continuity. right, then we have to identify f of a and f of b. So that's taking the endpoints of your interval and finding the value of them, the function value of them. And then make sure your desired value is between them. All right, and then we're going to make the conclusion statement. Now on your worksheet, that conclusion statement should be printed out. I made this print out before I added it to the worksheet. So anyway, the conclusion statement will be something like the following. So since f of x is continuous on a to b, and f of a is less than whatever that value is less than b, or you flip the order, that IVT guarantees there's some value, whatever we're looking for, on that interval such that f of whatever equals what you're looking for. So we're just basically going to say that statement over and over again until or for each one of these problems, just filling in different blanks. All right, so let's do some checks for understanding. Number one, if h of x is a continuous function on the interval from -3 to 7, and we know h of -3 is 10, h of 7 is -2, is there a guarantee that there is some value, a, such that, or in the domain, such that h of a equals 1? And then we have to justify the answer. So we start off at the beginning of the problem, and it tells you h of a is continuous. So we have satisfied that condition. So we'll start off with that. Since h of x is continuous on, and we'll go ahead and write our interval, -3 to 7. All right. So we've done the first part, verifying the condition of continuity. They told us f of a and f of b. So, or h of a and h of b. So h of -3 is 10, h of 7 is -2. What we want to do is make sure what we're looking for falls in between that. So 1 does fall in between, so we're looking for 1. So we would say and. Now the smaller of the three values is h of 7. So h of 7 is less than 1 is less than h of -3. All right, I'm just following the conclusion statement that's on your sheet. The intermediate value theorem, or IVT, guarantees there is some value, and in this case the value is called a, so we'll just follow what the words say in the problem, on the interval from -3 to 7 such that f of a equals 1. Alright, now sometimes it's not as laid out for us as that one, so let's look at the next one. For number 2, we're going to use the intermediate value theorem to prove that one solution to x squared plus x minus 5 equals 0 is between 1 and 2. Alright, now we're going to actually go through the steps on this one. So number 1, let's just go ahead and even though this is an equation, let's call it a function. So let's say we're going to let f of x equal x squared plus x minus 5. Now that is a polynomial function, and polynomial functions are continuous everywhere. So we're going to say, since f of x is a polynomial it is continuous everywhere. Okay, and let's look at number 2. Number 2 says to identify f of a and f of b. So even though this is not written as an interval, a is going to be 1 and b is going to be 2. So f of 1, we'll just take 1 and plug it in for all of our x's. So we'll square it, add it, and subtract 5 from it, and we're going to get negative 3. And then we'll do the same thing with 2. We'll square it, add 2 to it, subtract 5 from it, and we're going to get 5. Actually, I think this problem is supposed to be cubed. So cube it, add 2 to it, and subtract 5 from it, and we get 5. Sorry about that. Okay, so let's look at number 3. Number 3 says that we are going to check to see if our desired value is between f of a and f of b. So our desired value in this case is 0. So 0 is between f of 1, because f of 1 is negative 3, and f of 2, because f of 2 is 5. So the smallest is f of 1 is less than 0 is less than f of 2. And then we can write our statement. So since f of x is continuous, I'm just going to go ahead and use the interval. It is continuous everywhere, though, from 1 to 2. And f of 1 is less than 0 is less than f of 2. The IVT guarantees that there is some value, and we're just going to call it x because it wasn't identified as anything else, on the interval from 1 to 2 such that f of x equals 0. Alright, so for example 3, for each of the following, we're going to determine if the intermediate value theorem is applicable or not. And then we're going to say why or why not. So if it is applicable, we are going to go ahead and give our conclusion statement. Alright, so for A, that is a rational function, and rational functions are discontinuous at certain values. So let's look at this one. So this one, anything that is going to make you have 0 in the denominator will make the function undefined or discontinuous. So this function is discontinuous at x equals 1. And x equals 1 falls in that interval. So which is on the interval from negative 1 to 4. Therefore, the intermediate value theorem is not applicable. let's look at B. All right, so we already know that the function is discontinuous at x equals 1. Because it's the same function. However, this one has a different interval. We're looking at the interval from -3 to 0. So 1 is not on that interval. So which is not on the interval from -3 to 0. So f of x is continuous on that interval from -3 to 0. All right, then for number 2, we need to find f of -3 and f of 0. All right, so we'll put -3 in for our x's, and we're going to get 1 over -4, or -1/4. We put 0, we get 4 over -1, or -4. All right, then we go to our third step. Our third step is to check to see if the desired value is between those two. Our desired value was 1. 1 is not between f of -3. It's not between -1/4 and -4. So the intermediate value theorem is not going to be applicable. So we're going to say 1. Oops. 1 does not fall between f of -3 and f of 0. So the intermediate value theorem is not applicable. All right, so let's look at C. Now, I know I didn't give you guys very much space to get all this written, so to save space, this is the same interval as the one we just did, the same function as the one we just did. So I'm just going to say 1 and 2 above. We've already verified that the function is continuous on the interval. We've already found f of -3 and f of 0, so we don't have to do that again to save on time. Now, your problems aren't going to be like this. It's not going to be the same function 3 times, so you'll have to do it on each of these. But anyway, this time we want to see if we're guaranteed a value of -3/2. So this time, that does fall in between f of -3 and f of 0. So the smallest out of those 3 is f of 0, because that's -4, is less than -3/2, which is less than f of -3. All right, then we can write our statement of continuity. Not a statement of continuity, our statement of our conclusion statement. So for number 4, and I'm just going to just fill in the blanks of the statement we used. So since f of x is continuous on the interval from -3 to 0, and f of 0 is less than -3/2 is less than f of -3, the IVT guarantees there is some value and in this case we're calling it C, on the interval from -3 to 0 such that f of C equals -3/2. Now, you really cannot leave out a single part of that. You can't leave off the intervals. You can't leave off, saying what's between what. It has to look like that for you to get credit for your statement. All right. So your assignment is the topic 1.16 worksheet, but you're only going to do the A part. Tomorrow we'll talk about the B part.